I'll give you a little background about the class. It's the last class of the semester. We just had a little test. We did the first few weeks on basics of micro, and then we went through inequality, macro, econometrics, environmental, and sort of like a development, did a survey of like what upper div classes you might get. And the theme of the class is sort of going through these concepts and then having a Jupyter notebook to back it up and to have like a lab or a project that's sort of an in-depth computing assignment that goes along to illustrate some of the economic concepts.
Right. I actually looked at some of the slides, like the demand slide and the econometrics slides that you've done. Yeah. Great.
Well, I'll turn it over to you if you want to take over.
Okay, and this is a class. Who are our students? Who's our audience here?
All right. How many?
Who's our we always, as economists, say who's our representative agent?
Yes. So there's how many freshmen? How many sophomores? How many juniors? How many seniors? Pretty
oh my gosh, everybody.
How many econ majors? How many data science majors? How many business majors? How many, what else? Philosophy majors. Nice.
Okay. All right. Well, I'll give a kind of some ideas about what I think of as data science, the way that I work at Amazon as a consultant a day a week, and I have a lot of experience with the way they do what they call data science there. I wanted to give 3 lessons. I think economists, especially empirical economists like me, have a slightly different view on data work than lots of other fields. And so these are the 3 lessons that I think are kind of unusual coming, say, from a computer science or data science perspective, but are really, really important as an economist. The first I'm going to talk about is the build. The build is this process by which you create the data set that you're going to do your analysis on. And that oftentimes appears very superficial. Or if you're lucky, somebody says, go get this file off of this FTP site, and down you go. But more generally, that's the 90% of the research that I do is building. And so I want to talk a little bit about that. Related to that, I'm going to talk about the importance of descriptive modeling. This is how economists figure out what they are trying to describe, and also how they communicate with other economists what they are trying to describe. We don't, have a philosophical discussion about this or that. We show tables and slides and figures and show them to each other and say, okay, I got this, what do you got? And then I'll talk very briefly about causal modeling and research design. Okay, so the build, in most analytical or most empirical projects, this is the big effort to build an analytical data set. And for someone like me, that's everything. A project dies or comes to life based on the build. And a typical project will involve something like this. I'll have access to a huge data set, like all of the people in the US who receive or pay into the unemployment insurance system. And I'll have data on their quarterly earnings at each employer, and I'll be trying to focus on something about what happens as they move across jobs. So I'll start with 200, 300, 400 million observations, sometimes even 10 times that. And then pretty soon I'm down to a few thousand by focusing on very specific things. And that's often the way that research goes. And it's really important for communicating what you're doing to other people to sort of explain where did all those data points go. And as I narrow my focus down further and further, how is what I'm left with representative of the overall structure? And did I make mistakes? And you'll see if you work as a research assistant for a professor that there's an old friend of mine, the first person I worked with as co-author, who's now the chief economist at the Census Bureau, named John Abowd. once explained to me that that's why they start the word research with a re, because you're going to be doing it over again and over again and over again. So here's a few things that I think I would really emphasize if I were a project as a fresh build. The most important initial thing is to understand the data sources. I'm always amazed at a company like Amazon. There's no code books for anything. We're relying on word of mouth. The person who previously used the data set says, well, I think this variable probably means that. In labor economics, that really doesn't work. That you'd get kicked out of the meeting for saying stuff like that. So you're really responsible for trying to figure out as carefully as possible how this data set was created. Was it created from a survey? Was it? These days, in the old days when I started was the same age as you guys, most of our data sets were based on surveys. And in many ways, those are cleaner data sets, although there's noise in the survey itself. We have one record for each person in the survey. We kind of know what the probability was that that person was included in the survey because that's what the sample design team has told us. And so a lot of traditional statistical analyses is starting from that point of view, that we understand our data set because we created it with a sampling frame. But these days, most of our data comes from administrative data sources or incidental data sources like websites or whatever. And so everything is all messed up. And for example, missing values and duplicate records are everywhere in data sets that most people are working with. And until you know why there are these extreme values and why there are these duplicate records, you don't understand your data set. And it's amazing how many times I'll have a research assistant or even a co-author, somebody who's got a PhD, been working for a few years, and we'll start digging around, something isn't quite working. We'll find out, well, actually, there's an amazing amount of duplicate records or missing records, or the match variable that we think represents a unique ID isn't unique. So that's extremely important. And I really can't emphasize enough how important that is to quality research. Of course, in a business setting, there's going to be a lot of trade-offs because people have to come up with answers very quickly. And so there's always a fine line about compulsively trying to document all the data sets and actually getting something done. In academic research, I would say we probably stray a little bit on the side of compulsively documenting everything, but I feel like over my career that has worked out on average pretty strongly. So I really believe in this. An ordinary project will involve merging together many data sets. So for example, I'm doing a study of the election of fellows to become National Academy of Science fellows, which is a very prestigious award. And trying to figure out how treatment of women in different fields has evolved over time in election to these awards, and if there's a there used to be discrimination against women, is there still some discrimination? How much affirmative action is there in different fields, and so on. And so we're merging together many different data sets, and we're merging together data from publication records with data sets on citations, with data sets on who's actually in the National Academy. And I would say the first 3 years of work on this project has been a lot of merge errors. As a practical matter, I've been doing research for 40 years in economics. I would say almost all merges are screwed up. And it's kind of hard to see all the anatomy of screw ups that can happen with the merge. But inevitably, what happens is somebody's working on a build project and they think in their minds that it's just clear as a bell. There's this data set and that data set, and they'll merge. And it turns out they won't. There'll be missing observations, there'll be duplicate observations, and that's going to drive everyone crazy until you can figure out exactly why data set A and data set B don't merge or don't completely merge. So just like it's important to understand the missing values and duplicate records in each individual data set, it's extremely important to understand why A and B don't merge exactly. And if you do work as a data scientist and you're using big SQL merges and things, it's pretty easy. Mr. SQL doesn't report back all the screw ups. Someone who's compulsively trying to study how their data set was built will want to see exactly which observations did we have from data set A that didn't merge with B, which from B that didn't merge with A, and why. So that's what I'm saying here, compare the input and output data sets. And then the final thing I would say about building a data set is it's a little different in my mind, the way this is done, than the way it's kind of taught in a lot of classes. So ideally, you're going to have your set of code, this giant program with multiple SQL calls, and it's going to combine everything in one beautiful notebook. That's not actually how you're going to do it as you actually do it. That's how you're going to archive it, but that's not how you're going to do it to actually get it done. What you're instead going to do and understand it. And from data set A, you're going to say, okay, of all the observations in data set A, these observations are the ones we're going to try and follow going forward. Freeze that. Now we're going to go to data set B, do the same thing. Things have happened and why A and B don't completely merge. We're going to go back and figure out A, back and figure out B, do the merge and freeze that. Then we're going to keep going in that kind of process. And if you think about it as not like I'm going all the way I'm Napoleon's army going all the way to Moscow, and I don't know if anybody's ever seen that famous map showing the size of Napoleon's troops as they marched across Poland and got all the way to Russia. He started out with hundreds of thousands and got to Moscow with almost nobody, and then tweedled home, frozen to death and starving. That's kind of the way that this is going to work. And so you have to basically think of it as a long march. And when you get across one river, you're going to take stock of where you are and try and then hold that constant. So you're never going to have to go back beyond that again. So I really encourage, when you're building a big data set, to think about it like a program where you're going to try and make advances and then kind of hold that constant and not have to relitigate it. And you'll find that that's an objective that is very difficult to meet, but good in principle. Next thing I want to talk about briefly is descriptive modeling. In my experience as an economist, there's just enormous value in descriptive modeling. What descriptive modeling is that compare different subsamples, like the men and the women that have jobs in the economy today. How different is their education, or the non-whites versus the whites? How different is the set of occupations they work in? Or the types of people that move from one city to another city versus the type of people who move in the opposite direction. So you can think of all the people that move from Austin to San Francisco, probably like 70,000. So there are people always doing everything, and it's very interesting to try and understand descriptively those comparisons. And it's amazing how someone who's got a little bit of experience, and it doesn't even take that long, a few years of experience as a data scientist or analyst in a given field, you'll start to realize that something doesn't make sense, because this descriptive comparison, which you hold in your head as being true, is not true in this particular data set. And 9 times out of 10, that's not because you're wrong. It's because the data set's screwed up. So we're always looking at a data set and saying, well, I think something should be true. Why isn't it true? And in my field of labor economics, this is really the foundation of how we analyze each other's work and think about whether someone really knows what they're talking about. For example, here I've given a simple equation. If you take wage observations from workers that you see their hourly wage, their education, and their age and their gender, you'll get an equation that looks like this, no matter what. You'll have the log wage is approximately 0.1 times years of education, plus around 0.05 times their age, minus some discount for gender, for female. That gender discount has been changing over time. It's not as bad as it used to be, but it's still present. And those coefficients will be roughly true. They're true in Brazil, they're true in Africa, they're true in Canada, they're true in the United States, every country I've done the projects in. And if they're not true, you've got something screwed up. It's not that you've discovered a new anomaly. It's that you've probably screwed up the data set. And those observational patterns and learning what they are and how they relate to previous studies really allows you to embed your study or your analysis in the overall framework. And it's surprising how you can sometimes impress people by saying, well, today I can see right now that the average wage differences between New York and San Francisco are, around 15% higher in San Francisco. 20 years ago, it was only 10% higher. So that's gone up 5%. That's the kind of thing that people will find compelling and helpful to understand what's going on. So you should say your data aren't ever that different. What I mean by that is almost everything you're going to discover in your data set should be discovered, have been discovered in some other data set. Once in a while, if you're extraordinarily lucky, you'll come on to something that no one has thought of before, but most of the time that's not the case. Last thing I'm going to talk about briefly is causal modeling. Causal modeling is an important topic, and it's kind of the key for microeconometric research of the type that I do. That's basically what we try and do. We try and find out what causes what to move around. I would say that our fixation in applied economics has spilled over to, and there's a lot of interest in political science and sociology, and these days even in computer science, and trying to figure out how to do causal studies. And in business, this is just extraordinarily important. One way that they're doing a lot of causal modeling in big tech companies is with A/B testing. So they're, in the middle of the night, they're changing all the websites around, and you go look for something, and you see that something's available for some price, and somebody else will see that that thing's available for a slightly different price. And so they're using sequences of experiments to try and learn about the market and what kind of choices and things can be presented to customers. In causal modeling, we normally think of some relationship between an outcome Y and an input X. And usually in the way that economists will summarize that is in some average response of Y to X, often a regression coefficient, a beta. And years and years ago, I had a colleague, unfortunately now deceased, named Alan Kruger. And Alan had been trained in the stats department sign, size, and significance. And that's the three words that I think are still extraordinarily important in causality analysis. So you look at an effect, an estimated effect of an X on a Y, and if the sign and size don't make any sense, 90% of the time, if the sign is wrong or the size is wrong or the sign is wrong, something is completely screwed up. You don't have the research design you've got, the data isn't really what you think it is. And so it's no importance to look at the significance. You'll see that amateurs and people who are new to causal inference get fixated on t-statistics and significance levels long before they figured out whether the sign and size make any sense. And I can say that number of times that I've gone into a seminar or started reading a paper and said, this can't possibly be true. This coefficient is 100 times too big, or it's completely the wrong sign. And that was probably the most important comment that I could make in reality. In economics, causality is equated with research designs these days. So what we have is a series of statistical techniques that are focused around different kinds of designs. Kind of treatment status and the control status. Everyone probably is familiar with some other simpler designs that you can get with observational data, like a difference of differences design. The regression discontinuity design, where you've got an eligibility for some program or eligibility for student aid or something like that, depends on a sharp criterion. A good example of that is the Medicare program. You're automatically eligible for Medicare when you reach age 65. So you see a change in the fraction of people who have health insurance and an immediate increase in the number of people in Florida who are getting cornea transplants. So it makes you worry about the 64-year-olds who are driving in Florida. So this is a good example of a research design. There's a lot of interest right now in seeing whether we could come up with data-driven algorithmic approaches that might possibly be able to replace research designs. And there is some research by economists and computer scientists often together trying to do that. So far, I would say the results are not particularly promising. They sometimes work, but they don't always. And it's very difficult to know for sure under what circumstances they are working. In fact, I would say right now in this area, we're back where we were in the early 1980s when I was a recent PhD student, and people were looking at very fancy econometric methods without research designs and deciding that they were cool and could be used, but probably wouldn't reliably uncover causality. And I'm a little bit afraid that that's possibly going to happen in the ML sphere, or it's possible that there will be some progress. So far, though, research designs are the kind of the uber alles. And if you're really trying to do a compelling story and you can do an A/B experiment, 9 times out of 10, that'll win the day. So let me stop there, and I'll be glad to take some questions.
I have a couple questions. Can you hear me?
Sure.
So one question I have is, a lot of your papers sort of start with this concept of there's a natural experiment. I think you sort of, have these ones where like, there's a wave of migration, or the, minimum wage changes. A little bit seems like the home run economists often like somehow luck into finding these natural experiments. If you're a student trying to do like a research project, what's a way that you can sort of find these natural experiments in a way that it seems like the well-published economists are doing? Is there a way to like go to the world and sort of find natural experiments?
So I think that in reality, you need to have some kind of substantive knowledge about the area that you're working in. So if you think about, I'm trying to understand whether putting poor people all together in one neighborhood is a good idea or a bad idea. This was an idea that a couple of different people looked at in the early 2000s, and one of the papers that I remember that was pretty clever was somebody said, well, actually, there's an interesting experiment here because Chicago tore down their large housing projects in the 2000s, early 2000s, and basically took all the families that were living there and dispersed them. So let's see if we can study those. But you wouldn't really know those kind of experiments, quasi-experiments, if you weren't really pretty up to speed on what's going on in the area. And by the way, the same thing is true of regression discontinuities and difference of differences. You really have to know the area and understand like what's been happening to really understand whether there's anything going on. And then you have to be a little bit lucky and a little bit, maybe a little bit crazy. Like say, okay, I'm going to try this as a quasi experiment, and somebody's going to say, well, that's never going to work because if I look at that carefully, New Jersey and Pennsylvania just aren't the same. That's never going to work. So, so-called natural experiments are not as good as perfect experiments. And a lot of times they can be flawed. And so part of the job is to try and look at them skeptically and say, this could be interesting, but I'm not entirely sure it's going to work.
Nice. I wanted to say, you certainly have an amazing record of mentoring undergrads at UC Berkeley. Like you have worked with undergrads doing their theses for decades now. Do you have any like tips to people who are going into econ honors thesis? Like what's a good way to take on an honors thesis project that you see being successful?
Well, I mean, economics is unfortunately, there's a problem with economics, which is the same in computer science. There's way too many students per faculty member. And so unfortunately, it's kind of a crowded situation, and you have to try and distinguish yourself or try and get the limited attention of the like 40 faculty members in the economics department, which have to be spread out over the 700 majors we graduate every year. And the math is even worse in this computer science department. So the popular departments are kind of under-resourced. And I think you have to know that and try and figure out, okay, well, find somebody, an upper year student who's working as a research assistant for somebody, and get them to introduce you to the faculty member. You know, we rely on informal networks just like everybody else. So if I remember who was she's now in the PhD program at agricultural economics, but her name was Michelle, and Michelle was working for me. She was a good assistant and really, you know, incredibly hardworking person. And I said something about something or other. She said, "Oh, have you met Alice?" And I said, "Alice, who's Alice?" And she said, "Well, Alice, well, she's the smartest person I've ever met." And I said, "Okay, get her in here. I'll hire her." So that's how people have to get introduced to faculty. And I think it's helpful to try and get introduced to faculty before your senior year, maybe in the second or third year, and then develop some kind of understanding of what somebody's working on. And once you start working in an area, I'm the hugest believer in this, because if you look at the papers I've written papers on all kinds of crazy topics. And once I start working in an area, I find out there's so many interesting things to do. And that's just inevitably the case. So there's enormous holes in our knowledge of virtually everything. I've never actually looked at this before. No one, when I started working on minimum wages in 1988, no one had ever studied the effect of the minimum wage on wages. So there was no research that actually said when you raise the minimum wage, how much do wages go up? Believe it or not, that's how bad it is. So there's often things like that. There's giant opportunities, but you have to get a chance to get a foot in the door. And so normally I find the best way is to try and be some kind of an apprentice for somebody that's doing some kind of research, because you're going to find lots of opportunities like that.
Nice, thank you. I have another question. I also have a podcast, and I was interviewing Stephen Levitt from University of Chicago recently.
Right.
And he was commenting that he really feels like the econ undergrad experience needs to move towards data science and bring more data science skills into the econ major. Or
I totally believe that too. I think I teach a class 142 that tries to do that. We do some machine learning stuff. I think econometrics could use a lot of the same ideas that are common in data science, like bootstrapping and various techniques for using data-driven procedures. And there's a lot of really creative ideas and in terms of presenting data. You know, a Python can do the most amazingly beautiful graphs. You can tell, I mean, just from the basic thing, like for instance, the colors look good. So a Python graph just looks better than a Stata graph. It's got nicer colors and right from the get-go. So I think that there's a lot of creative thought has been put into how to display things, how to give people the options to do data description work. And that's why I sort of mentioned this descriptive modeling, because I think that's something that a data scientist without even a PhD can really contribute to.
Nice. So I personally have an issue where sometimes it seems like there's a bit of a coordination problem for the econ undergrads, where sort of like who teaches econ 140 changes each time, and what program it's taught in, or coordination between stat 20 and econ 140. Like in the case of econ 142, like you really were able to like own that class and evolve that curriculum. But like how can we provide a pathway for these students within their like lower division classes?
Right. Okay. I can tell you one day, a few years ago, I was chairman of the economics department, and a student had written a letter to the chancellor. saying how disappointed she was that she was a junior in economics and just couldn't get a class. They were all full, and many of the classes were taught by lecturers. I mean, I think our department is doing a much better job of getting really good lecturers, but still a lot of the undergrad classes are taught by lecturers rather than faculty, and they have some difficulty because they might not have the course for very long. So it's hard for them to make huge investments. Mm-hmm. So I would say if everybody in this room that is interested wrote a letter to Chancellor Christ and said, more resources for students in economics, it would be very helpful. because I think, and same in computer science, if you're a computer science major or data science major, say, give us more resources. We need more contact with, all kinds of people, senior faculty, junior faculty, really good lecturers who are committed to the university, people who've got another job and do some teaching as an adjunct. Those kind of people can really contribute too, and really make an overall package that's helpful for all students.
Nice. Those are my questions. Who's got a question from the class? Rohan. Back to writing an honors thesis. Can you tell what's a great honors thesis or what's not a great honors thesis? And can you tell before the project starts?
Not before the project starts, but probably within 2 months. Within a month or 2 months, between a month and 2 months. I always tell people when I'm working with a PhD student, it takes them 2 years to get a topic, usually. And there comes a time in that 2-year process, they're just dying because they really want to get a good topic and it's really important for their careers. And it's going on and on and on. There'll be some day they'll come walking into my office with something, and that'll be the day. And all of a sudden they have it. And I've seen that. I've had more than 125 PhD students, and I've seen that 125 times. It's really an amazing thing that suddenly it all makes sense. There's a kind of a framework and a question. A question and a framework, I guess, really. And that it's the question and the framework that are really the two things you have to get together. And it takes a long time, but I feel like if you get it, you'll see somebody will just say, okay, that's a great idea, go for it. And even some of my more skeptical colleagues, like Professor Moretti, or somebody who's pretty hard ass when it comes to like, this is a good idea. If there's a pitch and somebody says, here's the question, here's the framework, he'll go, okay, go for it. So you want to get to that moment as soon as possible. And so it involves a kind of a combination of what's a question that's interesting and informed by what the current literature is and where we are, but also show some creativity, possibly some new angle, and what's the framework to answer it.
Nice. Peter.
I remember hearing somewhere that Professor Clark chose to move away from studying physics to studying economics. And I was curious to hear about his motivation moving from physics to economics. And would he have made the same decision if he was an undergrad now?
Did you get that question? We heard that you were a physics.
Me, yeah. Okay, I actually took computer science courses back in the day. They're not like courses today. They were, but I don't know. I think that I'd be very interested in that. The computer science is less formal than economics or math, right? It's like, if you got a good idea, in 90% of the proof, that's pretty good. Mm-hmm. And so that's a very interesting environment, and there's a lot of really creative people in that field right now. And so I think that is really something that you should think about. It's always great to be in whatever field the most interesting, creative people are in. I mean, that's often more important than anything else. So I think I would be tempted to think about something that was more that way. But to tell you the truth, economics interests me because it's about people. And there's a lot of problems people face that aren't going to be solved by an algorithm. they're going to require something kind of a little bit different than that. And so I think there is always going to be a really important role for economics, even if it's a little different than it is right now.
Nice. Anybody from the class want to ask a question? All right, well, let's say thank you then.
Thanks, Eric.
Pleasure to have you. Thanks for coming.
Okay.
Great way to end the semester.
Okay, bye-bye.
Bye. Yay, that was cool.